Hello, Math 20s. This is the second lesson for proportional reasoning, and it's really related to the last lesson. So it's kind of solving problems with rates. So this is even more word problems. I know we saw some word problems yesterday, but there's more for this. So those of you that struggle with word problems, keep in mind some of the strategies that we've talked about, thinking about even bringing a highlighter out and highlighting things that are important, kind of writing out what you know, writing out what you're actually looking for, starting to break down all of those words into the specific important things, right? Word problems, there's a lot of words and only some of it is actually valuable for solving it. So you need to kind of filter that out and think about it. Don't give up on a word problem because it's just the same as something that's super straightforward. So you need to kind of filter out what's actually important. So this very first one, it says Martin is shopping for a new MP3 player. The one he wants is on sale for $119.95 at Giant Electronics, and that's in his town. So just like Best Buy or something like that. He found the same MP3 player for $105 US on a website for a US store. Today's exchange rate is $1 US for $1.08 Canadian dollars. So this is basically exactly like those questions that we saw yesterday for converting $80 Canadian into US dollars or something like that. So don't get stressed out by word questions. They're the same type of questions. You just have to be able to extract that important information. So it says determine which store has the lower price in Canadian dollars. So we're looking at Giant Electronics being one of the stores. And the website. And so it's asking in Canadian dollars, so that's at CAD. So Giant Electronics is already in Canadian dollars, so we don't need to do anything for that. Oops, it's $119.95 in Canadian dollars. Whereas the website from the US will quote it in US dollars, so 105.99 US dollars. And now we need to use this conversion factor. So this is what that big table from yesterday's lesson or last day's lesson actually was doing. It was converting $1 US to how many equivalent Canadian dollars. So I need to use that conversion factor. So I want to put my Canadian dollar on top. So 1.08 CAD, Canadian dollars, is the same thing as $1 US. So in my calculator, I'm going to punch in 105.99 multiplied by 1.08. Then I could put this divide by 1, but if you're dividing by 1, it's the same thing. So just multiplying the US price by 1.08 gets us 114.47 CAD. So this one is the lower price, right? 114 is less than 119. Do we need to convert it into Canadian dollars to be able to compare it? So next question is just kind of a thinking question. What factors besides the list price should Martin consider before he makes the purchase? So what other things? Yeah, it's $5.50 cheaper. So what else should he consider? So things like when you're buying something from the States, there might be shipping costs, right? It wouldn't really be worth it if shipping was $10 because then you're paying $124. So shipping costs, I know I've been not scammed, but sad to find out things like taxes and duty at the border. So when you order something, it'll say something at the bottom that says like taxes and duty may be extra. And most of the time I order things from the States, they don't end up having taxes and duty. I don't know how it gets decided when it does and when it doesn't, but sometimes, yeah, you've ordered something and then all of a sudden you have to pay $19 in taxes and you wouldn't have ordered it originally, but you've already paid for it, so you can't really go back. It's the worst. The other thing he could consider, or he might consider, so he could walk down to Giant Electronics and get that MP3 player and be listening to it on the way home. Whereas if he orders it online and Canada Post and the US Postal Service are busy with Christmas gifts, it might take him a couple of weeks. So like he needs to think about like how fast does he want it? You could also say something like shopping local, right? You want to support employees in your local area for having jobs and that sort of thing. Um, what if it's broken when it arrives? So what if it doesn't work? Then you have to pay to ship it back. So there's lots of kind of things to think about when shopping online versus shopping local, more than just the actual cost, right? I will say that I'm torn with the old Amazon situation these days. It's cheaper, it gets to my house fast, but I so would rather purchase something from a local store or something like that, right? But it's hard because it's cheaper and so many things on Amazon you can have delivered to your house the next day. So the lazy in me wants that, but again, shopping local and that sort of thing. So yeah, just my little soapbox, you know, you guys can't object to what I'm saying these days. So question 2, it says an airplane travels 300 miles in 36 minutes. At this rate, how far will it travel in 2 hours? So we're given pieces of information in which we can develop a rate. Something I didn't talk about on that last slide is this part up here. So there are typically multiple approaches to problems involving rates. So there's usually there's quite often more than one way to reach something. And so this is kind of the first question that I thought about it. So when I was solving this, like we're dealing with time in 2 different ways, right? I have something in hours and I have something in minutes. So we need to be able to relate those things. So what I did first is I converted 2 hours into minutes. So I know that 1 hour is equal to 60 minutes. So I can just go 2 times 60. And so again, I guess I should try to do the same thing. I'm going to get rid of my units of hours because it's in my numerator and denominator, and I'm going to be left with minutes. So 2 hours is equal to 120 minutes. Now I want to find out the rate that the plane is going from these pieces of information. So we know that it's traveling 300 miles in 36 minutes. So to get our unit rate, we need to divide 300 by 36, and that gets me 8.3 repeating miles per minute. So again, that's a unit rate because it's saying per one of something. So per 1 minute, the plane is traveling 8.3 miles. And so now what I can do is I can take that 8.3 repeating miles per minute, I'm going to write it like this, and multiply it by the amount of time that we're looking for. So we're looking for that 2 hours, which I converted to 120 minutes. So again, we're going to have my units on the top and bottom cancel. We're going to be left with miles. So 8.3 repeating multiplied by 120 gets us 1,000 miles. So when the plane is traveling at that rate, if we let it go for 2 hours, it's going to travel 1,000 miles. So with this one, we also could have converted 36 minutes into hours. So 36 minutes is actually 0.6 of an hour, right? 30 minutes would be 0.5 or half an hour. 36 minutes is 0.6 hours. So taking 36 and dividing it by 60 will get you how much of an hour it is. And then I could have figured out what its speed was in miles per hour and then multiplied it by that too. So different ways that you can approach it using your conversion factors. Sorry. I always panic that it stopped recording and that I'm wasting my time. We're good. Okay. Okay, so the next one. So Sam bought a used fishing boat in the US and brought it back to Canada. According to the literature that came with the boat, the gas tank holds 25 gallons. The marina where Sam docks his boat sells gas for 1.08 or $1.08 per liter. Determine the cost to fill the tank at this marina if 1 US gallon is equal to 3.785 liters. So gallons is something, it's a unit of measurement in the imperial system, which the US is very fond of, but we would use things like liters instead. But again, they bought the boat in the US, so like the manual that would come with it would be related to US quantities. So we need to figure out, we need to convert that, again, thinking about what's important. So the tank is 25 gallons. We're selling the gas, so this is the rate at $1.08 per liter, and then we have a conversion factor that will allow us to figure out how big the tank actually is. So 25 gallons multiplied by this conversion factor, that 1 gallon is equal to 3.785 liters. So I'm going to multiply it by that conversion factor. So we're going to have our units of gallon canceling out. So 25 times 3.785 gets us 94.625 liters. So now we know how big the gas tank is in this boat. Oh, sorry, I'm trying to drink coffee. Oh man, I spilled it all over myself. I need to pause. See, even when recording, real life things can happen. All right, I'm back and ashamed I'm such a mess. Okay, so now that we know how big the gas tank is, let's use that rate for the pricing of gas. So we know that gas costs $1.08 per liter. So, and we know how many liters we have. So 94.625 liters multiplied by that rate of $1.08 or $1.08 per 1 liter gets us a total cost of $102.20. So $102.20 is the cost to fill the tank of that boat. I mean, that's pretty pricey, but I guess if you're buying a boat, you might have money. Okay, one more. Okay, so this one's a bit of a process. You'll see there's an entire page available for it, and I end up taking most of the page when I write it out. So, oh my gosh, I don't even know. So a man from Morocco, ran 1,500 meters in 3 minutes and 26 seconds in Italy in July 1998. Me too, I can run real fast. Under a year later, he ran the mile in 3 minutes 43.13 seconds on the same track. Determine his average speed in kilometers per hour for each race if 1 mile is equal to 1.6 kilometers. So there's a couple different things. This is a little bit of a beefy one. So we have 2 races. So we have the first race where he ran 1,500 meters in that amount of time, and then we have a second race where he ran a mile in this amount of time. And we have our little conversion factor. And again, it's asking us for the speed, the overall speed of that. So I'm going to call it race 1. So that's the one in 1998, and we'll call the other one race 2 in 1999 because it says it's a year later. So we're looking for his speed in kilometers per hour. So I know I'm actually going to have to convert 2 things. I'm going to have to convert meters to kilometers, and I'm going to have to convert miles to kilometers. So our conversion factor between meters and kilometers, a kilometer is bigger and 1,000 meters fit into it. So 1,500 meters multiplied by that conversion factor, that 1 kilometer is equal to 1,000 meters. And so that gets us a distance equal to 1.5 kilometers. So again, that's the distance that he ran in kilometers instead of in meters. Now the confusing thing with this one is kind of the time thing. So it says 0, 0, and then a colon, and then 0, 3, and then a colon, 26, and then decimal 0, 0. So I'm going to skip out those first two zeros, 0, 3, 2, 6, 0, 0. What that means is it means 3 minutes and 26 seconds. It is not 3.26 minutes. 3 minutes and 26 seconds is actually not 0.26 of a minute because there's only 60 seconds in a minute. So what we need to figure out is how much of a minute is 26 seconds. So we know 30 seconds would be half a minute or 0.5 of a minute. So it's going to be slightly less than that. So using our conversion factors, 26 seconds multiplied by our conversion factor of there's 60 seconds in 1 minute gets us that 26 seconds is equal to 0.43 repeating minutes. So 3 minutes and 26 seconds is actually 3.43 repeating minutes. But again, it was saying in kilometers per hour. So now we can convert it into hours. We also could have converted, I guess we could have converted 3 minutes into seconds and then converted from seconds to hours. Again, there's usually is more than one approach to get to it. So we know that there are 60 minutes in 1 hour. So again, your units of minutes are disappearing, canceling out. And so 3.43 minutes is actually equal to 0.0572 repeating hours. So this is the time. So we have a time, we have a distance. I gave you this formula yesterday that speed is equal to distance divided by time. So in this case, it's going to be distance in kilometers divided by time in hours. So our distance in kilometers was 1.5 kilometers. Our time in hours was 0.0572 repeating hours. So this gets us a speed for his first race of 26.2 kilometers an hour. That is ridiculous. That's so fast. When I was my best at running, my very best, I couldn't quite run a 10-kilometer race in an hour. I was always a little bit more. So I can run it slower than 10 kilometers an hour. And this person can run like 26 kilometers an hour. That is insanity. I blame my little short legs and my terrible lung capacity. So let's look at his race 2. And so again, that's the one in 1999. So we want to figure out the distance and time again so that we can calculate the speed. So his distance for this one, it says 1 mile. So remember, we want our speed in kilometers per hour, so we need to use that conversion factor that was up at the top. So 1.6 kilometers is our distance. So you see he ran slightly farther in this second race because we had 1.5 kilometers in the first race, but now he's running 1.6 kilometers and it's taking him slightly longer. So, same thing as last time. So 0.4313 represents 3 minutes and 43.13 seconds. Yes, in like Olympic races and stuff like this, they take it down to the thousandth of a second sometimes because races can be so close depending on the sport. So converting that 43 seconds, 43.13 seconds into a minute. Hang on to our units. Seconds. 1 minute is the same thing as 60 seconds. So this gets us 0.71883 repeating minutes. So this, as just minutes instead of minutes and seconds, is 3.71883 minutes. Now we need to convert that into hours. So we know there's 60 minutes in 1 hour. So 3.71 and so on minutes is actually equal to 0.06198 hours. And so this is our time. We're getting close. So just like we had above, speed is equal to distance over time. So that's speed, the distance was 1.6 kilometers. The time was 0.06198 hours. So that gets us a speed of 25.8 kilometers per hour. And so you can see if it asked you to compare in which race was he faster, he was actually faster in the first race. It was a little bit shorter. So maybe if he ran the full mile in the first race, maybe he would have been a little bit slower. So that is the problems with rates. Your homework is on page 458, I believe. If you didn't get the things done from page 450, make sure you look back at those. Thanks so much. We shall see you all later.